Okay, let's get into it. It is February 10th, 2026. We're a full month into the new year, and I have to ask, if you've been glued to your news feed, refreshing X or, whatever you use, waiting for that one massive frontier model to drop,
That GPT-6 moment.
that GPT-6 moment, or the Gemini Ultra Max, or whatever we're calling the God model these days,
Yeah.
you might be feeling a little, well, underwhelmed.
It has been strangely quiet, at least on the surface, if you're only watching for the big press releases.
Right. I mean, the headlines aren't screaming bigger, better,
Yeah.
trillions more parameters anymore.
I know.
It feels like the entire industry just took a collective breath and sort of shifted gears while we were all looking the other way.
That is actually the perfect way to frame it. If you look at the signal beneath the noise in January, the whole era of scaling up just for the sake of it has, well, it's paused.
Okay.
We're not just building bigger brains anymore. We're building hands, eyes, and frankly, better budgets.
So we're moving from how smart is it to what can it actually do?
Yeah.
And this is the big one. How much does it cost to run?
Precisely. The conversation has moved to deployment, to efficiency, and surprisingly, to physicality.
Physicality.
We're looking at systems that don't just chat, but systems that interact with the world. And we're looking at the massive financial toll of building the infrastructure for all that.
That's the perfect setup.
Yeah.
So for this deep dive, we've gone through a huge stack of January reports, VC updates, technical papers, some pretty stark financial disclosures.
Yeah.
And we found 4 massive pillars that are really defining the landscape right now.
Right. To give you the roadmap, here's what we're covering. First, the graduation of agentic AI, semi-autonomous systems that finally seem to work.
Okay.
Second, a concept that is technically fascinating, but also a little unnerving. The recursive AI trains AI loop.
Which is the part where the machines start checking their own homework.
And writing it too. Third, we've got the explosion of world models, things like Google's Genie 3 that are trying to understand physics, not just text.
Right.
And fourth, a strategic twist that I think a lot of Western observers are missing. The huge adoption of Chinese open-weight models in U.S. tech stacks.
And we absolutely have to talk about the price tag. We're going to close out looking at the Infra arms race.
Yeah.
Specifically, Meta signaling a plan to push capital expenditure into the $100 billion range.
Yeah.
And the very real human cost, the 72-hour work weeks that's fueling this whole engine.
The stakes have never been higher. I mean, this isn't just a software update anymore. It's a global allocation of capital and energy.
So let's jump into pillar number 1, the agents.
Let's do it.
Back in 2024, agents were the buzzword of the year. Every startup promised their chatbot could book your flight and order your groceries.
And file your taxes.
Right. But usually it just hallucinated a confirmation number, booked a flight to the wrong city, and then timed out.
It was the demo era. Great videos, terrible reliability.
But looking at the January reports, it seems like the agent has finally graduated.
It has. The shift we saw in January is that agentic AI is no longer just a feature request. It's the product.
So we're moving from systems that talk
to systems that do.
Write me a poem about a pirate and more. Go analyze the spreadsheet, email the client, and update the database.
Precisely. But the difference now is the autonomy. In 2024, you had to hand-hold the agent through every single step.
Right. Open the file. Read a column A.
Draft the email. Now we are seeing high-level goal-seeking. You give it the outcome, reconcile these counts, and the model plans the sequence, executes the tool usage, and crucially, it error checks itself.
That error checking part is key, isn't it? Because that was always the failure. It would make a mistake and just confidently plow ahead.
Right. The new architectures have a reflection step. The agent acts, observes the result, critiques it, and then acts again. It's a feedback loop.
Ah, okay.
And this actually ties directly into that second pillar we mentioned, which is where things get really sci-fi. AI trains AI.
Yeah, let's dig into that. Because AI trains AI sounds, well, recursive, like a snake eating its own tail. Are we talking about robots teaching robots?
In a very literal sense, yes.
Okay.
We're seeing the emergence of automated AI researchers and continuous learners.
Okay.
Think about the old paradigm, the one we've been in for the last 5 years. You train a massive model, let's say GPT-4 back in the day, it takes months. Then you freeze it, you ship it.
And it's static.
It's static.
It's like buying an encyclopedia. It's out of date the moment it hits the shelf. If I ask it about something that happened yesterday, it has no clue.
Exactly. But the new R&D direction, which was a huge theme in the January papers, is systems that improve themselves post-deployment.
So the software I buy today could actually be smarter next week, not because the engineer sent an update, but because it learned from its own work.
That is the goal. We're seeing self-play techniques, kind of like how AlphaGo learned Go by playing millions of games against itself, being applied to reasoning and coding.
Wait, okay, apply that to coding. How does that work? AlphaGo had a clear winner and loser. How do you win at coding?
That's the brilliant part. Imagine an automated developer agent. It writes a piece of code to solve a problem. Then it runs the code.
Right.
It sees an error message. Instead of giving up, it analyzes that error, rewrites the code, and tries again. It generates its own training data, the bad attempt and the good fix, and updates its internal weights based on that experience.
So it's not just accessing a database of answers, it is actively running experiments.
It is generating synthetic experience. This is a game changer for businesses because it moves us from software depreciation, where your tools get old, to software appreciation.
Your tools get sharper the more you use them.
Exactly.
That creates a compounding value that is just, it's hard to wrap your head around.
Yeah.
But it also demands a new way of thinking about control, right? If the system is evolving on the fly, how do you make sure it's evolving in the right direction?
That is the alignment problem, but on steroids. If you have a system rewriting its own instructions, you need very, very strong guardrails. But assuming we can solve that, it opens up the next frontier. If these agents are getting smarter, they're also breaking out of the text box.
Which brings us to world models.
Yes. This was the standout theme from CES 2026 and the whole January news cycle. The industry is obsessed with physical AI.
Physical AI, I mean, it sounds solid,
Yeah.
but we've had robots for decades. What's different now?
Until recently, AI was great at processing language, but language is just a proxy for the world. It's a description. If I say the cup is on the table, that's just a string of text. It doesn't contain the physics of friction, gravity, or the fragility of the ceramic. World models try to process the reality itself: physics, 3D space, cause and effect.
And we've got some specific examples here. Google's Genie 3 and something called Overworld.
Right. Genie 3 and Overworld are showcasing this much richer 3D interactive understanding. Genie 3 isn't just generating a video, it's generating a playable environment. It understands that if you turn a handle, a door opens.
But the one I really want to highlight is DeepMind Sima 2. DeepMind is usually at the cutting edge. What makes this one so special?
It's designed for cross-world generalization.
Okay, hold on. That sounds like jargon. Cross-world generalization. What does that actually mean in plain English?
So think about a video game or simulation. An AI might be trained to be a god at, say, Minecraft. It knows every recipe, every block.
Right.
But if you drop that same AI into Fortnite or Grand Theft Auto, it's completely useless. It doesn't know how to move or interact.
Because it just memorized Minecraft. It didn't learn how to be an embodied agent.
Exactly. Sima 2 is about an embodied agent figuring out the meta rules of navigation. It's learning, oh, I have a viewpoint. If I press forward, the visual field changes. If I hit a solid object, I stop. It is learning the concept of movement and interaction in a way that transfers from one world to another.
So it's moving from processing the word chair to understanding what a chair is in 3D space. That it has volume, that you can sit on it, that if you run into it, it might tip over.
Perfectly put. And why this matters to you, why you should care, is that this is the precursor to robotics that actually work in your home. If you want a robot to fold laundry in your bedroom and then go wash dishes in the kitchen, two very different worlds, it needs this kind of generalization.
It's escaping the screen. We're finally getting the brain that can drive the body.
We are. But here's the twist. You'd think this is all happening in Silicon Valley in the closed labs of, the usual suspects, Google, OpenAI, Anthropic.
Right.
But our sources point to a really surprising shift in the underlying architecture of all this.
This was the part of the research that honestly surprised me the most. Western startups companies based in San Francisco and London are strategically adopting Chinese technology.
It's happening quietly, but it is massive. We're seeing growing usage of models like Qwen, DeepSeek, GLM, and Kimi in Western tech stacks.
I feel like that runs completely counter to the main narrative we hear in the press, which is all about the AI Cold War, the chip bans, the separation of ecosystems.
It does.
But you're saying U.S. companies are putting Chinese models into their stack.
They are, and it isn't political. It's pure economics. It's about open weights.
Explain that distinction for us.
Sure. The big U.S. labs, OpenAI, Google, they mostly keep their models closed. You pay for an API call. You rent the intelligence.
Right.
Many of the top Chinese labs, specifically DeepSeek and the Quinn team at Alibaba, have released their model weights openly.
So you can download them?
You can download them, you can inspect them, and most importantly, you can modify them. So Western startups who are trying to manage burn rates are looking at these and saying, why should I pay a fortune for a closed US API when I can take this high-performing Chinese model, distill it, prune it, and run it on my own servers for a fraction of the cost?
So it's just a pragmatic play. It's about cheaper inference and ownership.
And control. You're not dependent on a giant tech company changing their terms of service or, deprecating a model you rely on. You own the instance.
Yeah.
And technically, there have been some fascinating architectural breakthroughs coming out of these labs, specifically DeepSeek, that make them incredibly efficient.
Yes, I saw this in the technical notes. DeepSeek's Enneagram. It sounds like something out of a cyberpunk novel or a neuroscience textbook.
It does, doesn't it? But the concept is brilliant. It introduces conditional memory.
Conditional memory. How does that differ from how models usually work?
Imagine you have a massive brain. Usually in a standard dense model, to think a thought or answer a question, you have to activate the whole brain. Every neuron fires.
Right.
That takes a massive amount of energy and compute.
Which is why these things cost millions of dollars a day to run.
Exactly. Enneagram. And the broader trend of mixture of experts, it decouples knowledge storage from reasoning compute.
So it's like, if I ask you a question about baking a cake, you only wake up the part of your brain that knows recipes, and you let the part that knows about astrophysics sleep.
Roughly, yes. It creates these active experts and allows the AI to know more, have a massive storage of facts without thinking slower or burning more energy. You don't have to crunch through astrophysics data to boil an egg.
That makes so much sense for efficiency. It feels like we're finally optimizing the code rather than just throwing more chips at it.
It is the definition of optimization. And there was another term that popped up in the January papers, manifold constrained hyperconnections.
Oh boy. I practiced saying that 3 times before we started. Manifold constrained hyperconnections. It sounds like something you'd say to Scotty to fix the warp drive.
It really does, but let's demystify it.
Please.
Think of a neural network as a city with roads connecting every house to every other house. That's the old way fully connected. It's messy and traffic is slow.
Right.
Manifold constrained essentially means we're building superhighways along the most important routes.
So we aren't just adding more roads, we are paving the ones that actually get used.
Exactly. It's a method proposed to push performance without just lazily adding more parameters. The old way was add more neurons. This new method is about making the connections between them smarter, more sparse, and more direct.
So the theme here, whether it's engrams or hyperconnections, is smarter sparsity.
Better latency, cheaper inference. It's not just brute force anymore, it's elegance.
But speaking of brute force, we have to pivot to the other side of the equation. Because while the software architects are getting clever and elegant, the infrastructure side is going absolutely nuclear.
This is the Infra arms race. And if you
Okay.
follow the money, the signal Meta sent in January is deafening.
Yeah, let's talk about that. Meta Facebook signaled they plan to roughly double their AI capex. We're talking about pushing it into the $100 billion plus range.
For a single year.
Just pause on that number. $100 billion.
That is the GDP of a mid-sized country. That is more than the entire Apollo program cost, adjusted for inflation, spent in 12 months.
It's just mind-boggling. What are they buying? Is it just NVIDIA chips?
It's chips, yes, but it's mostly physical infrastructure. Land, power, data centers, concrete, cooling systems.
Wow.
This is why I say AI is no longer just a software challenge. It is a capital allocation challenge. If you're Mark Zuckerberg, you are betting the entire future of the company on this.
It's a land grab. He's trying to build the railroad before anyone else can lay track.
Exactly. And he's not alone. Microsoft, Google, Amazon are all in the same boat, though Meta was the loudest about it in January. But there is a bottleneck that money can't easily fix.
People.
The human cost. To deploy that much capital and build that fast, you need labor. You need researchers, engineers, and we're seeing reports of 72-hour work weeks becoming the norm.
72 hours. That's 6 12-hour days or 7 10-hour days. That is just brutal.
It brings back memories of the dot-com boom or the early days of Silicon Valley, but amplified. The competition for top researchers is fierce, but the pressure to deliver is crushing.
It's a paradox, isn't it? We're building these agentic AIs to automate work, to make things efficient, to train themselves.
Right.
We just spent 10 minutes talking about how elegant the new models are, and yet the humans building them are working harder than ever.
It's a symptom of the high stakes. The feeling in the boardroom is that the winner takes the infrastructure advantage for the next decade.
Hmm.
If you fall behind on the deployment phase, on getting those data centers live, on getting those models trained, you might not catch up. So they are sprinting.
It puts that $100 billion into perspective. It's not just money, it's intensity.
Yeah.
It's almost panic.
It raises a big question for the sustainability of the industry. Can you burn out your best talent in the race to build the machine that replaces the labor?
Or does the quality of the work just suffer when everyone is sleep deprived?
Exactly.
Wow. Okay, let's take a breath and zoom out. We have covered a huge amount of ground today.
It's a dense landscape.
We have the rise of agents that act and correct themselves. We have world models trying to understand physical reality.
Cross-world generalization.
We have this quiet revolution of Chinese open weights DeepSeek, Quen making AI cheaper and more efficient through things like engrams.
Right.
And looming over it all is this $100 billion infrastructure war and a grueling human toll.
It's a split screen. On one side, you have elegant, efficient technical breakthroughs, smarter sparsity, conditional memory. On the other side, you have brute force capital and brute force labor.
So for you listening in, whether you're a builder, an investor, or just someone trying to figure out where the world is going, what is the takeaway? How should you position yourself in 2026?
The advice from the sources is clear. Don't get distracted by the lack of a GPT-6 headline. That is the old game.
So what's the new game?
Focus on infra efficiency and agentic workflows. If you're building, don't just ask which model is smartest. Ask which model can actually do the job cheapest and fastest.
And keep an eye on those open weight ecosystems.
Absolutely. The Chinese models are a strategic lever. If you ignore them because of geopolitical bias, you might be overpaying for inferior performance. And finally, look at the physical world. The jump from screen to reality robotics, simulation, spatial computing is happening right now.
And I'll leave you with this thought to mull over. We talked about AI trains AI and DeepSeek's Enneagram, this idea of decoupling memory from reasoning.
Right.
We're building systems designed to learn continuously without getting tired and to access vast knowledge without slowing down. So, are we approaching a point where the human 72-hour workweek becomes the bottleneck? Or will these agents eventually take over the rush itself? Are we sprinting to build the thing that finally allows us to stop sprinting?
That is the multi-trillion-dollar question. And frankly, with the pace things are moving, we might know the answer before the year is out.
Thanks for diving in with us. We'll be watching to see who or what crosses the finish line first.
See you next time.
Catch you on the next Deep Dive.